This wall looks perfectly dry from the room, but open it up and the insulation is soaked. The sheathing is dark. The water did not leak in from outside. It was built by the wall itself. Dry outside, wet inside. Recap in one breath. Indoor air carries invisible vapor. Vapor turns to water on any surface colder than the dew point. On windows, you can see it. But vapor does not stop at surfaces. Vapor travels into the wall. Inside the assembly, temperature falls step by step. Warm at the drywall, freezing at the outer face. Somewhere along that slope sits the dew point plane, a hidden line inside your wall. Vapor migrating outward crosses that line and meets the first cold surface beyond it, usually the inner face of the cold sheathing. There, invisible vapor becomes liquid water, right inside the wall. This is the condensation plane. Two transport routes carry moisture into the wall. Route 1, diffusion. Vapor slowly seeping through materials themselves. Route 2, air leakage. Room air flowing through gaps, carrying moisture in bulk. The gap wins by orders of magnitude. And here is the loop. Wet insulation insulates worse. The cold side gets colder, so even more vapor condenses. The wall quietly feeds its own problem all winter. This is the self-reinforcing loop. The design principle used worldwide? The warm side rule. Slow the vapor on the warm side, keep the cold side open enough to dry out, and seal the air path. In cold climates, the warm side is inside. In hot, humid climates, it flips. This is climate dependent. Error 1. Trusting paint and drywall to stop moisture. They barely slow diffusion and do nothing against a gap. One missing strip of air barrier can outweigh the entire wall. The gap beats the paint. Error 2. Adding vapor-tight layers on both sides. A wall that cannot dry in either direction traps every drop it ever collects. Moisture needs an exit route. No drying path equals trap. Error 3. Copying a wall recipe from another climate. The same assembly that works in a cold climate can fail in a hot, humid one. The dew point plane moves to the other side. Climate flips the rule. Quick recap. Vapor travels into the wall. Where temperature crosses the dew point, water forms, hidden. Air leaks carry most of it. Warm side slows vapor, cold side dries, and climate decides which side is which. That closes Node 3. Next, Node 4, thermal bridges, the cold highways that cut through your insulation. Node C01-004 next,